Hello everyone, I Sonali Mate welcome you all for the session of Dynamics of Machinery. So now we'll be discussing unit number 4, that is balancing. So under this unit we'll be discussing about what is balancing, what is need of balancing, different types of balancing, and we'll be seeing balancing methodology in various types of system or in various types of machines. Under this video we'll be discussing about introduction to balancing, a brief overview on balancing. The learning outcome is student will be able to understand the term balancing. They'll be able to identify the types of balancing. Let's talk about balancing. So in our childhood, everyone have seen or played on seesaw. It is nothing but at the center it is fixed and at the both the ends there is a place to sit for the children's. So imagine if a healthy boy is sitting on one side and the weaker boy is sitting on the other side. So can you say that they'll be able to play? No, because the heavy side will go in the downward direction, whereas this weak boy will go in upward direction and they will not be able to play. What you can say when the system will be balanced or what when the system will be in equilibrium, then the masses of both the children will be exactly same. So then you can say that this will be in equilibrium condition or they will be in the balanced condition. Another example is of weighing machine. In our daily life or when we go in the market or even in any shop, here you can see that there is a weighing machine. In earlier days, it was used on a used number. So when you can say that this machine is balanced, when the masses on both the sides is exactly same, then it achieves its equilibrium position. Otherwise, it remains unbalanced. Also, one condition is there that both this should be on equal distance from the center point. Here in the seesaw also you can say this distance is almost or it is same. So this is the rough overview of balancing or balance system. You can say that system is balanced when on both the sides there is equal amount of mass at equal distance. So next is types of forces acting on the systems. So there are two, that is static force, which is due to the dead weight of the machine component, and the another is inertia or dynamic force. This is due to the acceleration of machine components. So you can say that dynamic forces are generated when the system is in motion, and static force is generated when the system is at rest. Now static force is very negligible, whereas dynamic force, its magnitude is more than the static forces. So it becomes a crucial point to consider these dynamic forces which leads to the unbalance and which leads to vibration. This becomes hazardous. So there is need to study the effect of dynamic forces. It means that we should know what is the need of balancing. So here is the example of a wheel. This green color shows you the unbalanced mass, and this unbalanced mass generates the centrifugal force when the wheel is in motion. Now here you can see initially when the wheel is rotating at slower speed, there is no unbalance or this unbalance is tolerated. But as the speed increases, your centrifugal force increases. The centrifugal force is nothing but force acting in the outward direction and it depends on speed. So as your speed increases, centrifugal force increases and this leads to increase in vibration. So imagine that the wheel is vibrating at such a large amplitude. So what will happen? So this wheel is connected to a car, and when this wheel has such a large vibration, it will transmit this vibration to the car and the other components of the car. So ultimately, it will transfer vibrations. Parts, machine components will also vibrate, and this will leads to the failure of the component or the system. So from this, you can imagine that unbalanced mass or unbalanced force is a very crucial topic which we have to consider while designing a system. So here the other example is of compressor. Now this compressor is vibrating due to unbalanced couple over here. Now there are the two masses, one is over here on this region and one is on this region. So this two masses generates the unbalanced couple in the system, and this gives some angular position to this shaft. So basically this leads to the vibration. So imagine if compressor is vibrating at a large amplitude, then it is very dangerous. So balancing is an important topic which we have to consider while designing. So what is balancing? It is a process of eliminating the unbalanced forces or the couple acting on the system. So unbalanced force and unbalanced couple should be eliminated. Now this may be eliminated either completely or partially. It is not that always we can completely balance the system. There is some amount of error. So our practice is to balance the system either completely or partially. So when you will say that the system is balanced, so here you can see that there is a wheel and there is an axis of rotation. This axis of rotation is passing from the center of mass of the wheel. When there is such condition, then there is no unbalance. So you can say the system is balanced. So the system is balanced when the center of mass will lie on axis of rotation. If the center of mass does not lie on axis of rotation, then there is some amount of unbalance in the system. Then that unbalance should be overcome by balancing the unbalanced force and unbalanced couple in order to reduce the vibration. So here is another example. Here this is one type of seesaw. Now as we have to balance the system, let's talk about how to balance. So first type is that now from this is the center point. From this point the distance of this mass, and from this point the distance of this mass is, it is same. Now in this case what we can do is, if suppose this mass is of 30 kg. So to balance this mass, either we have to add the mass of 30 kg, one mass, or you can add this three masses each of 10 kg. So this is one way of balancing, that we have to add equal amount of mass in the opposite direction at equal distance from the center point or from the axis of rotation. Okay, so here is the 30, so you have to add 30 over here. So this will balance your system. And the another example is, here you can see there is a boy whose mass, if suppose it is m1, and here is a girl whose mass is m2. Now from the diagram also you can see, and we can say that m2 is greater than m1. Now in this case, if we have to balance this system without changing the mass, then in that case we can change the distance. Here you can see this is R2 and this is the R1. R1 is the distance from center to the boy and R2 is the distance from center to the girl. Okay, so this R2 is less than R1. So imagine M2 is greater and R2 is smaller. So this becomes M into R, and similarly, or this is M2 and R2. Similarly, here it will be M1 into R1. Your product should be same. It means we are balancing this force. This is nothing but your centrifugal force. What is centrifugal force? It is given by mr omega square, and omega is constant. So simply we are balancing the product m into r. So simply for balancing purpose, we should either add mass at equal distance or we should change the distance in order to keep this product constant. So this is how we can balance the system. I hope you have understood. Thank you. For any queries, you can contact me on my email ID. And if you have liked my video, kindly like, share and subscribe.